All right, guys. Happy Monday. Hope you're doing okay. Hope you did all right on that quiz. You feel confident in what you're doing. We're going to begin to look at a new type of AP review problem today, and then we'll continue with that Wednesday and Thursday. Tomorrow's going to be a little bit different, but I'm going to wait to give you those instructions till tomorrow. So the next type of problem that we have, the most common type of problem, especially with calculator active questions, are called rate in, rate out problems. We started to look at these earlier in the year. We've done some parts of these before, but essentially what you have is you've got something. You've got some tank or location or table or whatever, and what you have is you've got a certain amount of stuff that you start with. Something enters that tank, building, table, whatever, at a certain rate in, and it exits at a totally separate rate, which is rate out. And the reason they ask these questions, they like to ask these questions, why I think this is a great candidate for the AP exam, is because it requires you to think about a few different things. If it is a rate at which something is moving in, that's like a velocity. So you can ask acceleration questions with derivatives, integral questions with the amount. Also, if the rate in versus the rate out are different, you can make sure that people understand and look at different functions together, that they can coordinate and organize different types of information. And here's the other thing. If you think about the amount of, let's say this is the amount of gravel that shows up at a work site. If we start at 500 and we've got gravel being added, but also at the same time you have gravel being taken out, right? So the level of this increases and decreases. It goes up and down all day, which is a third function. So this is a function, this is a function, and then this right here is like a combination of those two things as a function. So there's a great place to ask max and min questions. So I just think this is a great candidate for the exam, and I want to run through a few of these. Good news is they're pretty standard. Bad news is that there's lots of parts to them, and you have to be able to interpret the question fairly quickly. So let's go ahead and do that. As we go through and look at Part A. Part A says the following. Part A, I've started with some easy ones this week. We're doing the easier examples at the beginning. We'll get to more challenging examples at the end, although I will tell you that Part D is the more challenging of the problems today. Part A, find G prime of 5 using the correct units. Interpret your answer in the context of the problem. So let's read the problem. On a certain workday, the rate at which unprocessed gravel arrives at our plant is modeled by this function. So what I've circled in black here, that function is the rate at which things arrive. T is measured in hours. We have from 0 hour in our workday to hour 8 at our workday. At the beginning of the workday, there's 500 tons of gravel there, so we'll circle that. 500 tons of gravel is what we start with. We process gravel. That would be the rate out. We process gravel at a rate of 100 tons per hour. So let's think about what we got here. For Part A, find G prime of 5. Well, that should be an easy thing, guys. The primary thing that you're going to do is you're going to plug that into Y1. There's going to be a calculator video that goes with this. So in Y1, you're going to type that out, making sure you're in radian mode. Maybe you're even super careful and put the numerator in parentheses. And anyway, that's in. Well, G prime of 5, that's just going to be math 8. And then you can use Y1. You don't want to have to retype this function over and over. But for Part A, you don't write that. You don't write that on the AP test. What you write on the AP test is G prime of 5 equals, I'll show you how to do this in the calculator. When you put this in your calculator, you'll get negative 24.588. And so now we have to think about what that number means. Well, if G represents the rate at which gravel is showing up, then the derivative of that, G prime, represents how that rate is changing. In other words, since G is kind of like a first derivative, it's like a velocity, G double prime is like an acceleration. And so the way that we would write our answer is we would say the rate at which gravel is arriving at T equals 5 is decreasing, right? That's what that negative means, is decreasing by 24.588 tons per hour. You can even write out the word per. So that's the first part, that's part A. Guys, part B is super easy. Part B you should be able to do almost in your sleep. We read part B. Find the total amount of unprocessed gravel that arrives, so the amount that arrives during the hours of operation. So that's simply the integral from 0 to 8, because that's our hours of operation are from 0 to 8, of our function, which is 90 plus 45 times the cosine of t squared over 18 dt. Guys, you just put that into Math 9. You put that into Math 9, and you'll get 825.551 tons. Put a unit with it. Here's the thing, too, guys. If you don't want to write all of this out here, since that function is being expressed as g of t, an alternative is to write the integral from 0 to 8 of g of t dt. So an alternative, instead of writing this all of this out, you could just replace it with that part. You have to have the dt, you do have to have the limits. Another variation of this question is sometimes they say, what's the average amount? And so if they ask you the average amount, you would just, let's say this question was average amount, you would just put 1/8 on the outside, and so you'd have 825.551. You divide that by 8, you get about 103 point something. So that's a variation on question B. Okay, guys, let's look at part C. You'll notice I erased what I had. I'm doing that. You can always rewind the video if you need to see what I wrote before. I'm just doing this so I can look at the question and answer it at the same time. For part C, is the amount of unprocessed gravel, so that's an important word there, is the amount of unprocessed gravel increasing or decreasing? Well, let's think about this, guys. It's kind of like before when we did position, velocity, and acceleration. This is the amount of gravel. This is the rate at which it is coming in or out, and acceleration would be how that's changing. That's like what we did on part A right here. So if they're asking, is the amount increasing or decreasing, increasing and decreasing comes from the first derivative. Well, what is the first derivative of the amount? Well, the first derivative of the amount is rate in or rate out. Here's what's great about this, guys. They give us the rate in and the rate out. So in other words, the rate in, the amount of the rate in is at 5 seconds would be g of 5. So I'll show you how to do this on the calculator in the calculator video, but g of 5 would equal 98.141 tons per hour. However, what is the rate out? What is the rate out? The rate out would be the amount of gravel that's processed. We process at 100 tons per hour. Since the rate out is the larger of the two, that would mean the amount of gravel is decreasing. So that would mean the amount of gravel is decreasing. So what we can say is the amount of unprocessed gravel, so we'll say the amount of unprocessed gravel at t equals 5 is decreasing since 100 is greater than 98.141. We have told the AP grader, look, I know that the rate out is bigger than the rate in, and so therefore the total amount would be decreasing since more is leaving the plant than is arriving at the plant. All right, guys, part D. Part D, I think, is the hardest part of this problem. The question is, but it's common. They ask this a ton, and so they're going to want to see this. What is the maximum amount of unprocessed gravel at the plant during the hours of operation? So, look, we have a lot of different times that we can look at, but we'll say time and amount. So where do maxes and mins occur, guys? Maxes and mins occur at endpoints. So one endpoint would be 0. The other endpoint would be 8, because 8 would be the end of the day. And also any place where we have a critical number. Critical number of what? Well, a critical number of the amount. We don't have a function for the total amount of gravel. So we have to create a function for the total amount of gravel. So I'll say the total amount of gravel according to time is going to be what we started with, 500, minus 100 tons per hour. So that would be minus 100 times time, plus the integral from 0 to t of our function, right? So we have what we started with, minus how much we processed, plus how much we've added. That's the amount function, and that's an important function. We're going to need to use that function in a second. But remember that the maxes and mins occur at the derivative. So what's the derivative of this? Well, the derivative of 500 would be 0. The derivative of negative 100t would be negative 100. And the derivative of an integral would be plus g of t. Maxes and mins occur where the derivative equals 0. So where does this equal 0? I'm going to show you that on the calculator, but I'll tell you now, since I calculated it, that could occur. Another point is 4.923 seconds. 4.923 seconds. So I'll show you how to do that on the calculator in the calculator video. But this isn't the end of the question. They want to know what is the maximum amount. So I have to fill in this column on the right. Well, t of 0 is easy because they give that to me. They tell me in the problem t of 0 is 500. Right? When time equals 0, there were 500 tons of gravel on the plant. These other two, I have to use this equation I just wrote, and I'll do this in my calculator. I'll show you how to easily do this in your calculator to figure out what this is. What is A? Basically, what is A of 4.923? What is A of 8? And I'll tell you for part D that this would be 635.376, 635.376, and this other one would be 525.551. Those are our two values. And so what is the maximum amount? The maximum amount of gravel at any one point during the day is 635.376 tons. What I wrote in or what I put a square around in black, you would want to actually write that out. You would want to say the maximum amount of unprocessed gravel over this time interval is 635.376 tons. Part D is a tough one, but I'm telling you guys right now, if we're only having 2 questions on this AP exam and this is on there, this one's going to be maybe the difference between a 4 or a 5, could be the difference between passing and failing. So pay attention, look at what it is, practice tonight, watch the calculator video, and if you have any major questions, please ask me. We've got contact now, so I want to help you if I can. We'll do more practice later in the week. Hope this helps. Have a great day.